How are you, friends? It's good to be back again to speak about engineering once more. Yeah. So today I thought of doing a video and explain some basic concept about shear in flexural elements. Shear in elements which are subject to bending. Examples of slabs, examples of beams. Members which are subject to bending. They do fail by shear. Apart from bending, they also do fail by shear. And so I think it is important for a designer to really understand what exactly shear is, the concept behind shear. So that is what I want to go through very quickly, so that we understand exactly what shear is. So as usual, I'll just do some sketches as we explain it, as we go ahead. Well, so maybe let me just do a sketch of a beam. Maybe you have a beam. This is a beam that is too. Well, you have a beam. For this example, let's just assume it is simply supported on both ends. So it is simply supported here. It is simply supported here. Well, if we subject this member to some loading, we have an external load. We have some loading over here. We have some external loading over here. Which is can be distributed uniformly over the beam, or it can as well be a point load, maybe at the center. Point load at the center here. What will happen is that this beam will be subject to shear. So if you cut a section through this point, let us cut a section through this point here where this load is being applied. If we cut a section there, so what we'll be having is let me just draw that. We have this one here. We have a section at this point, and it is supported here. So we have shear force in this direction, the downward direction. This force here, I mean this external load is trying to cut this beam at this point, right? We also have reaction force, at this point, this support is a reaction force, so that reaction force is going in this direction. So we have shear forces. We have a force here, and we also have a force here going in the opposite directions, going in the opposite directions. These are the shear forces. Now, if we take an example, well, if you go to a site and look at a beam which has failed in shear, most of the time, what you do find on site is something of this sort. You find that it has developed cracks which are nearly 45 degrees. Well, they can't be 45 degrees exactly, but nearly there. They form some kind of diagonal cracks. From the edge here, they develop diagonal cracks. That is actually shear failure. But how does that one occur? How does that one occur? That is the most interesting part of this video, right? And so what really do happen is this. If you take, maybe let's take a small particle at this point here, then let us explode this so that we have that particle as this member here. We have it as this element. Now what will happen to this element is that we have a shear force going in the downward direction, we have a shear force here. We also have a shear force at this point. So we have an element, which is this. Then we have a shear force on this side. We also have a shear force on this side. What will happen? This is actually a couple, right? This is actually a couple. So this member will tend to rotate, right? It will tend to rotate in this direction. So we expect it to be rotating in this direction, but it actually won't rotate. Why? Because this element here is having some other surrounding elements. You know, we have elements here, we have elements here, we have elements here, we also have elements here, right? So it has surrounding elements, so it will not actually rotate. You know, it has a couple. There's a couple here, a force in this direction and a force in this direction. So we expect it to rotate, but it won't rotate. Well, if it rotates, then we'll have something of this kind. We expect it to be something of this kind. We expect it to be something of this kind. Yeah, but in this case it won't rotate because we have other elements which are surrounding it. So what will happen in that case? Well, because we have other elements here and also here, what will happen is that there will be shear force. You know, because these elements are also resisting the rotation of this member, the rotation of this element here. So there will be shear force developed between this element here and the surrounding elements, right? So there's the shear force developed. Well, we also have another shear force here, which is developed between this member, right, and also the surrounding elements. You know, because it is stopping this member to rotate in this direction. So we have a shear force there, and we also have one there. So this is just an exploded element here. So what will happen? We will have a resultant, you know. So we have a resultant in this direction, because this force here and this force here will give us just but a resultant. So what we'll have at the end of it all, what we'll be having at the end of it is something looking like this. Something looking like this. Let me take a different color for that. We'll have something. We'll have something looking like this. This is the element. We now have our resultant force in this direction. That is tension. And also because we have two forces here, we have resultant tension in this direction, right? Yeah, so what will happen eventually? Yeah, it will try to crack the diagonal here. You know, because of this tension and this tension, it will try to crack this diagonal here. Hence the idea, it will try to crack here. Hence the idea of 45 degrees crack in Flexural members. Well, I think that is good enough. That is the basic idea. The basic idea, you know, in beams. So how do we go about that when designing? Well, what you have to ensure is that the concrete, the sectional area of this concrete here, you have to ensure that the sectional area of this concrete here is sufficient to take care of that shear, right? But most of the time you'll realize that for the sectional area of this member here to be sufficient to carry the shear, we'll have a very big section, right? That is why we end up providing the stirrups, you know. So you'll find stirrups. If this is your beam, then you'll find stirrups either vertical or diagonal stirrups. That depends with the designer. So you find stirrups, the links here, which are used to just take care of the shear. So that is the basic idea behind it all. I think I just want to stop it here. Kindly remember to subscribe to this channel so that we make it more vibrant. Also make sure that you share with your friends, right, so that we all learn together. I'll really love to hear your comments, so in case you have any comment, please just put that in the comment section. I will for sure follow and reply to the ones I can. That is it. If you want to also add some ideas, feel free to always reach me. Thank you so much. Please subscribe and share. See you in the next video. Thank you.